Let's take a look at how to solve a harder trig equation. As we're progressing along, the equations are getting a little more complicated. So we see this equation, we see cotangent squared equals 2 cotangent x times cosine x. We realize that we have a cotangent in both of those. We need to resist the idea of trying to divide that out. Just say no. Instead, when we see that, what we need to do is move them to one side. Remember, never, ever, ever divide out a function. When we move it all to one side, we'll get cotangent squared minus 2 cotangent x cosine x equals 0. Now we see that we have our cotangent, so we can factor that out. We'll get cotangent x times cotangent x minus 2 cosine x equals 0. We can set each one of these factors now equal to 0. So we'll have these two. Now in order for cotangent x to be 0, cotangent is cosine of x over sine x equals 0. What we are really solving there is cosine x. In order for the fraction to be equal to 0, the numerator must be equal to 0, while the denominator is not. Now how do we go about solving this? The first thing that we should be drawing is our unit circle. So we draw our unit circle and we say cosine is what value on the unit circle? Cosine is x. So if we're looking at x, the whole thing here, equals 0, x equals 0 is our vertical line, and it is the y-axis, and it hits at 2 points. We have x equals pi over 2 as well as 3 pi over 2. Now we can come over here and take a look at this, and we'll have cosine x over sine x. And note we're going to have a cosine. We can just write a cosine is going to be common to both of those. We could factor that out as well. If we had realized that earlier, we could have just factored that out immediately if we had switched it all into sine and cosine. We've already solved this one. That's the same thing that's on that we had just take a look at the other piece. We'll have 1 over sine x equals 2. Remember, if two fractions are equal, their reciprocals are equal. So that means that sine x equals 1 over 2. At this point, we will draw our unit circle. And on the unit circle, sine is a y value. So we're looking at where does y equal 1/2. So this top piece is 1 because it's a unit circle, unit being 1. We're going to go to 1/2 and we'll draw a line going across. Where does that line hit the circle? Now we need to practice our unit circle values always, and we should know that this value here is pi over 6, and then this value in the second quadrant will be 5 pi over 6. And recall we have a reference angle of pi over 6, so we could say pi minus pi over 6 gives us 5 pi over 6. And that is an example of how to solve one when it is an exact value, a unit circle value. Let me show you another one now. This one is going to be a little different. We'll have 3 sine x equals cosine x. There are two standard ways to go about solving this particular problem. The easiest one is to realize what would happen if I divide both sides by cosine. And while we're at it, we could just divide by the 3 as well, and you'll see why in just a second. What do we get on the left side here? The 3's go away and we're left with sine. Is that? Tangent. And then over here the cosines go away, and so we'll have a 1 on the top and a 3 on the bottom. Now you might ask yourself, hey, didn't you just say never, ever, ever divide out a trig function or any function? Notice here, am I dividing it out of the problem? No, I'm moving the cosine to the other side. This allows me to use my unit circle to solve the problem. Now we know that tangent equals 1 at the 45, so it's going to be something less than that. It'll be a line somewhere along these lines, this one here, and we need to now find those two values. Is 1/3 a unit circle value for tangent? No, it is not. So we need to take out our calculators. Let's see here, and we'll make sure we're in the proper mode. Yes, we're in radian mode. Now let's go inverse tangent of 1/3. And that gives us 0.317. So we can write x equals the inverse tangent of 1/3. And that is approximately equal to 0.32 rounded to the second decimal place. That gives us our first angle, and how do we get the second angle? Well, we can see that there's this line plus the angle we have. So we're going to take pi plus 0.32. And instead of using just 0.032, we're going to use all of our decimals on the calculator. So we just hit plus, and you see how it shows up, answer plus. And now we can say the pi button. So press second to get and then the pi button, and we get 3.46. 3.46. So we have two answers, and there they are. Now in this particular case, it would have worked out if we said 3.14. Just say no to that. We want to do it properly so we can round at the very end, not at an earlier stage.